Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, lesson 15, the distance from a point to a line. All right. Well, in this one here, this lesson, the distance from a point to a line. So let me just explain what they're saying here. So if we have a line, let's do this. If I have, let's just say this line right here, and I put a point not on that line, and I draw a segment randomly over like so, or let's say over here. The black line is longer than the red line. And if I were to swing this like a pendulum, the actual shortest distance from a point to a line is a perpendicular line. Okay, so the blue line is shorter than the red line, and the black line is longer than both of them. So the further I go away from that point, the longer the distance to that line is. So the shortest distance I can get to a line is a perpendicular. So we could also think of it in terms of a circle. So if I had a circle centered at that point and I drew the circle out like so, the circle's radius is perpendicular to this line, and we call that a tangent. I'm getting a little ahead of ourselves here, but this is coming in very soon in the coming lessons. Okay, so I just need you to be aware that the distance from a point to a line, shortest distance, is a perpendicular line. So in this problem here, it says a robot is moving along the line 20x plus 30y equals 600. A homing beacon is at the point 35, 40. Where on this line will the robot hear the loudest ping? So if I had a robot, let's just say this is the robot here. Okay, it's hearing a ping as it's going along this line, like so. It's going to get louder and louder the closer you are, and it's going to be the loudest when it's perpendicular. And then if I keep going, then the ping is not going to be as loud. It's going to get fainter until you can't hear it anymore. So louder, 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 loudest. Not so loud, quieter, 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 can't hear it. Okay, does that make sense? So this problem is saying that it's asking where on that line will the robot hear the loudest ping? In other words, what point on this line would be perpendicular to that point there, the distance? So if there was a line here, where is this point that the point of perpendicular appears? And that is actually, this is a right triangle here. The blue black or the blue red, so that is dropping a perpendicular, which we've already done. Okay, so there's a few ways we can do this. The first thing I could do is find the slope of this line. So if I take 20x plus 30y equals 600, and I don't remember that the a and the b tell me what the slope is, then I can put this in slope-intercept form by doing this. Subtracting 20x over to the other side. Forgot my zero. Okay, 20x plus 600. And then I divide the whole thing by 30. So that's every term by 30. And I would get y equals negative 2/3 x plus, and 60 divided by 3 is 20. So there is the equation of the line in slope-intercept form. So my slope is negative 2/3 and my y-intercept is 20. Okay, so that's great, but then how do I finish this problem? Well, the other way I could do this, actually I've graphed this in a website called GeoGebra, so let's go over there. So as you can see over here, if you look over here, I have the equation 20x plus 30y equals 600. I left it in standard form. And here it is. And notice my equation, when I converted it to y equals mx plus b, slope-intercept form, it's right here. our y-intercept was 20 and it's going down to right 3. So if I go back to this graph, sure enough, y-intercept's 20. And if I go down to right 3, well, these are 5. So multiple of 2 would be down 2. So if I look at these bigger squares, 1, 2, right 1, 2, 3, there's a multiple down 2, right 1, 2, 3, and I'm at that 30. And the other way, if we want to review some more, whoops, I didn't want that. I want to go back to my lesson here. The other thing we could do is we could find the x-intercept and the y-intercept by making x 0 and making y 0 respectively, and that's what has happened on the other page. Now going back to that, I have graphed the point C. The point C is 35, 40. It's over here. So I want a line segment that comes down perpendicular to this, and that's what the question's asking. Where on this line? What vertice, what xy coordinate, I should say, would get me on the line that's perpendicular to C and some point here. All right, so going back to the lesson, let's continue. So remember that if a line is perpendicular, then the slope of the perpendicular is going to be the negative reciprocal of the original line. So I'm going to flip that over 3/2, and it's not negative anymore, it's positive. So I know the slope of the perpendicular is 3/2, and I have a point 35, 40. That is a point, that is the slope. We use the point slope formula. Y minus y1 equals m times x minus x sub 1. Substituting in our givens, y1 is 40, so it's y minus 40 equals my slope of 3/2 times x minus my x sub 1, which is 35. And there is the equation of the blue line, if you will, in my diagram up here. And if I wanted to put that in slope-intercept form, then all I have to do is continue with the simplification here and distribute and get 3/2 x. And 35 divided by 2 is 17.5 times 3 would be 35 plus 17.5, or 35, 45, 52.5 minus 52.5. And then I add 40 to both sides. And let me check my math real quickly on this. 3/2 of 35, just so I'm not going back and fixing. So 3/2 times 35 is 52.5. Okay, so then we get y equals 3/2 x minus 12.5. There's the equation of the perpendicular line. Where is the loudest ping? Where those two lines meet. Okay, so at this point, there are a few different ways we can do this. We have two equations. They're both equal to y, so they're equal to each other. Let's use the substitution, or in this case, the transitive property. So if y equals negative 2/3 x plus 20, and y equals 3/2 x minus 12.5, then negative 2/3 x plus 20 equals 3/2 x minus 12.5. So let's keep my x's positive. And let's get rid of these 2's and 3's. So I'm going to multiply this whole thing by 6. Okay, because that's the common denominator of 3 and 2. And so when I do that, if I multiply this by 6, 6 divided by 3 is 2. 2 times negative 2 is negative 4x. And then 6 times 20 is 120 equals 6 divided by 2 is 3 times 3 is 9x minus 6 times 5 is 30, carry the 3. 6 times 2 is 12 plus 3 is 15, carry the 1. 6 times 1 is 6 plus 1 is 7, and that is 750. So then I'm going to add 4x to both sides, and that's going to give me 13x over here. And I'm going to add 750 to here, and that's going to be 890. And then if I divide by 13, then I get my X. So okay, lesson 15 is called the distance from a point to a line. The distance from a point to a line. So the first thing I want to address here is what happens when you draw a line like so, and then you put a point not on that line, let's say right here. Well, how far is that point from the line? Well, it differs. It depends on where we are talking about on that line. And let me explain. So if I take and draw a line segment like this, okay, and that is a fairly far distance, okay, but if I then do it again with a different color and make it a different length, and I go say like down here even, okay, the distance that the blue line, the distance from this point to this black line going on the path of the blue line is shorter distance than this red one, obviously. And as you can see, the further I go down this line here, the longer the red line gets. And if I now draw one more segment, I'm just going to show you what's going to happen here. If you draw what we call a perpendicular, which we have been doing if we don't have a right triangle and we want to use trig, the distance from a point to a line, the shortest distance is the perpendicular. So the green line is as close to that line this point will ever get. So if I had a beacon, like they're talking about here, it says a robot is moving along the line, this line here, a homing beacon sits at this point. So if this was the beacon and this is a path of a robot, so let me just put an oval here or something to represent the robot. So here's the robot, okay? So if it is here and it starts hearing that ping of the beacon, it's going to get louder because this is getting closer to that point as we go. And then when it gets to this point right here, that's where it's going to be the loudest because the robot is the closest to that point. And then if you keep going, now we're getting further away again and the ping is going to start to get softer and softer and then we won't be able to hear it. Okay, come back, louder, 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 loudest, quieter, 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 can't hear it. Okay, so we're looking for the point that is perpendicular to the line from that point, and that's what this problem is asking us to do. So a robot is moving along the line here. So what I can do with this is I can take 20x plus 30y and set it equal to 600 like they have. I can solve this for y by subtracting 20x from both sides, and I will get 30y equals negative 20x plus 600. And then if I divide by 30 every term, okay, then the 30s cancel and I get y equals the zeros reduced down to 2/3 x. There's my slope plus these cancel. 60 divided by 3 is 20. So this is the slope-intercept form of this equation. Okay, so I've done this in GeoGebra. This is a program online. It's free, geogebra.org calculator. And I put the equation in just as it was, standard form, and it plotted this green line. And then I put the point 0, 20, and 30, 0 to show the y-intercept and x-intercepts. And if you go back to my equation, there's the y-intercept 20. Go back to the graph, there's the y-intercept 20. How do we find the x-intercept? Make y 0, okay? When y is 0, so then it would be 600. If this was 0, then x would be 600 divided by 20 or 30. Okay, so we've done those prior lessons or maybe even prior courses. Okay, so anyway, there's the equation of the line. So if I go back to the graph, that is the robot is moving along this line. Here's the beacon. It doesn't hear very well here, but we're getting closer to that point until we get to a point that is perpendicular to the line that this point C is on. And we're trying to find the point wherever that is, right here somewhere. Okay, I can't write on this, just have it. Okay, so that's what we're trying to do. Well, remember that in this equation here, the slope is negative 2/3. Okay, doesn't look good. Negative 2/3, and the y-intercept is 20. Keep in mind that the slope of a perpendicular line equals the negative reciprocal of the line that we already have. So we take that 2/3, make it positive, and flip it over to 3/2. So I want a line whose slope is 3/2 going through this point. Here's my point right here. So this is x1, y1. My computer's running out of memory or something. Okay, so point slope formula says y minus y1 equals m times the quantity x minus x sub 1. Substituting in, I get y minus 40 equals the slope of my perpendicular 3/2 times x minus x sub 1, which is 35. Okay, just to make this simple, I'm just going to add 40 over to the other side, and I get y equals 3/2 quantity x minus 35 times plus 40. So here is the equation of our line. I didn't distribute, but I don't want to because we'll get a decimal. This is the equation of our line. So how do I find where this line is going to intersect this line? Well, you see this y right here? We're going to substitute the value of y into that so that we find the x value that would make that true on that line. Okay, so in order to do that, let me switch to blue. We would do 20x plus 30y, but my y is 3/2 quantity x minus 35 plus 40. So 20x plus 30y equals 600. So we want to solve this. Okay, so we're going to get, I might as well stick with blue now. When I do that, I'm going to get 20x plus, and if I distribute this 30, times 3 is 90, divided by 2 is 45x, minus 30 times 35 is 1050. Okay, but we also have to multiply that by 3/2. So because this is distributed, so times 3/2, and that is going to give us 1575. So I'm just doing this all in one step. What you could have done is distribute this to here and here, and then distribute the 30. I just did it all at once. 30 times 3/2 is 45. 30 times 35 times 3/2 is 1575, plus 30 times 40, which is 1200. And that is going to equal 600. I'm going to combine like terms. So this is going to give me 47x plus, now it's minus, the negative is bigger. That is going to be minus 375. 1575 plus 1200, negative 1575 plus 1200 equals 600. And then finally I add 375 and I get 47x equals 579. Okay, and then I divide by 47 and I find my x value at that point. So I'm going to take 975 divided by 47, And that gives me, oh, I'm sorry. I'm checking my work. I missed this 20. Hopefully you caught that and are like, dude, you're doing it wrong. So let me just fix this real quick. 20 plus 45 is 65. And so this would be 65x divided by 65, and then divide this by 65. The 65s cancel, leaving x, and I want to do 975 divided by 65. That's better. That gives me what I got before, which is 15. So I know the point that is right here would be 15, comma, something. How do I find the y? Plug it into our equation. 20x plus 30y equals 600. 20 times 15 is 300, plus 30y equals 600. Subtract 300 from both sides, and we get 30y equals 300. Divide both sides by 30, and we get y equals 10. So there is my y, there is my x. So this is the point 15, 10. So let me check that. If I go to my graph here and I input the point 15, let me try that again. Can't use my pen. 15. Let me see. Delete. Try that again. Input, parenthesis, 15, comma, 10, close parenthesis, return. There's D right here. So if I drew a line now, what was the equation of my line that I got? I'm just checking this with my calculator. 3/2 x minus 35 plus 40. So now if I put y equals 3/2, let's see, delete, arrow out of that, 3/2 x, okay, minus 35 plus 40. So I need a parentheses here, 3/2 x minus 35 plus 40. Okay, and as you can see, I have a red line going through my point D, which was 15, comma 10, and it's going up, and it actually goes through the point C, which was at 35, comma 40. And these two lines are perpendicular because their slopes are negative reciprocals. Okay, so this graph proved or checked the work that we did here. So the answer is 15, comma 10. All right, so the next question is somewhere hidden here. Okay, so part B says at this point, 1510, how far will it be from our beacon? Well, remember, distance equals the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. So the distance is going to equal so x sub 2 is 35, comma 40. So x sub 2 is 35 minus x sub 1 of 15. Y sub 2 is 40 minus y sub 1, 10. So the distance the beacon will be from this is the square root of 35 minus 15 is 20 plus 40 minus 10, which is 30. Okay, so let me just, I don't need the parentheses anymore. 40 minus 10 is 30, and you square it. So now d equals the square root of 20, which is 400, plus 30 squared is 900. So the distance is 9 and 4 is, the distance is 13, the square root of 1300. Okay, or I could just do this. The square root of 400 plus 900. And I get approximately 36.05 or 36.06 units. Okay. I could also simplify that, and let's do that. So if I take the square root, let me just fix something here. Okay, so how do we simplify a radical? Factor tree, extend the page, and that is going to be, just a moment, get rid of that dash line, and erase this. All right, that's even, divided by 2. 6 times 2 is 12, remainder 1, 5, 0. Divided by 2, so 2 goes into 6 3 times, 2 goes into 5 twice, 2 goes into 10 5 times. It doesn't end in, it ends in 5, so I'm going to factor out a 5. 6 times 5 is 30. 5 goes into 25 5 times. I will factor out another 5. 5 goes into 6 once. 5 goes into 15 3 times. So I have a pair of 2s, I have a pair of 5s, I have a 13. So that is 2 times 5 square root 13, or 10 square root 13. This is the simplified radical of 1300. So 10 square root 13 is approximately 36.06 units. So if I look at my graph, the distance from here to there is that 36. Okay. Okay, page 2 brings us to exercise 2. It's going to be a little bit of a challenge, so be patient with me. I am not going to derive this formula. I've decided not to derive it here, but I am going to explain it using this diagram. So if we have a line and we call it y equals mx plus b, and this is the point not on the line, and we call the point x, p, comma, q for the y. So this equation is, here's the point R, that is the point where PR is perpendicular to the line L, and that R is the point, this is our X value, R, comma, Y. Well, what is this MR plus B? Well, Y equals MX plus B. Here's our Y. We're putting Y here. Since Y equals MX plus B, I put MX plus B here, but that's not an X. Well, X is R. So R, comma, MR plus B. Got it? I hope. This is a distance of 1. This is a rise of M. So that's our slope M, an unknown slope value M. So this is up M over 1, if you will, rise over run. The point T is another point on the line. So the R was X. So here's an X value. If I go to the right one, and it was 5, well, now I'm at 6, 5 plus 1. So this is the point R plus 1, okay, comma, M times R plus 1, okay, plus B. We're just adding 1 to our X, and our R is here, so that's M times X plus 1. And then plus B would be right there. So that's where these points come from. Hopefully you understood that. And then we're going to substitute in our givens. So let me explain. Here's the point P in this situation. So what is P and Q? Well, here's our P, it's 0. And here's our Q, it's 0. Y equals 10. Well, that's a linear equation. And if I have Y equals MX plus B, and I just have a 10 there, that's called a constant. That is a horizontal line with a slope of 0. So Y equals 10, the slope equals 0, and the B or Y intercept is that 10. So let me just keep these two and get rid of this equation here. Move these over here. So what do I know now? That doesn't really look like a Q, so let me rewrite those. This is our point X on the P, which is P, and this is our Q. Okay, so what do we need in this equation? We know that the distance, there's a P, that's our X. There's a Q, that's our Y. There's an M, our slope, that's a 0. There's a B, that's 10. So is there any letter in here that we have not represented yet? We need a P, a Q, an M, and a B. P, Q, M, P, B, M, M, P, Q, M, 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 B, M, B, Q. That's it. We've covered it all. We only need these 4 values to find that distance rather than doing what we did here. All that work right there is going to be replaced by this formula. So here goes. Distance equals, all I'm doing is a substitution problem now. P, 0. So I'm going to put my parentheses, 0 plus Q, 0 times M, which is 0, minus B, which is 10, times M, which is 0, all over 1 plus M squared, minus P. Okay. Close the parentheses, squared, plus parentheses, M, 0. Parentheses again, P, 0, plus Q, 0, times M, 0, minus B, which is 10, times M, which is 0, all over 1 plus M squared, close the parentheses, plus B, 10, minus Q, 0, quantity squared. Okay, that was a really long process. I apologize for going over into my diagram, but there it is. So now we simplify it. So how about I just fix this for you so we're not over the diagram. Okay, so I just slid that over and here we go. Now we just need to simplify. D equals, well, 0 plus 0 times 0, well, that's 0. 0 plus 0 is 0. Minus 10 times 0 is 0. All over it doesn't matter because anything 0 over anything is 0. Minus 0 squared is just simply 0. Plus 0 plus 0 times 0 minus 10 times 0. That's times 0. Everything gets zeroed out. Plus 10 minus 0, which is 10 squared, is 100. So D equals the square root of 100. So the distance is 10. All right, I already knew that just because if you have a line going through the origin and it's horizontal, y equals 10. I'm sorry, the P is 0, 0. So let's show this in GeoGebra. So if I go to GeoGebra, I just want to explain this. So let me just clear all of this. Delete, delete. Actually, I think I can just do clear all. There we go. Don't save. All right, so let's go back and what do I have? I have 0.00 and a line y equals 10. That's all I'm graphing. So I'm going to put a point in 0. Whoops, I can't use my pen for this. Put that down, use the mouse. 0, comma, 0. Enter. Okay, there it is right there. And then I'm going to put y equals 10. Enter. So we're looking at this point right here. Well, how far is it from there? Perpendicular to it is the y-axis, and it's a distance of 10 because it's a vertical line. Okay, so that was just a basic example to show that this works. But now we're going to do another equation where the P 0, 0, so that's my P and Q, and the line y equals 1x plus 10. So my m equals 1 and my b equals 10. So I have p, q, m, and b. That's all we need to do this formula. And now we're going to find how far is a point on line y equals x plus 10. That would be a perpendicular to a line going to the origin. That's what we're trying to find here. So it's, again, simply the substitution problem. So d equals the square root of, and we're just going to use this formula up here. And it says p 0 plus q 0 times m minus b, let's say minus b times m all over, there's a parentheses here, 1 plus m squared minus p. Close the parentheses, square it, plus parentheses m1 parentheses p0 plus q0 times m1 minus b times m, 10 times 1, all over 1 plus m1 squared. Close the parentheses, plus b 10 minus q 0. Close the parentheses again, squared, and extend my square root symbol. D equals 0 plus 0 times 1, which is 0, is 0, minus 10 times 1, which is 10. 0 minus 10 is negative 10. Okay, divided by 1 plus 1 squared, which is 1. 1 plus 1 is 2, minus 0 squared, plus 1 times 0 plus 0 times 1, which is 0, that's 0, minus 10 times 1, which is 10. 0 minus 10 is negative 10 over 1 plus 1 squared, which is 1. 1 plus 1 is 2. And then we're going to do plus 10. Minus 0 is 10. And all of that is squared. So D is going to equal the square root of, well, negative 10 divided by 2 is negative 5. Squared is a positive 25. Plus negative 10 divided by 2 is negative 5, times 1 is still negative 5, plus 10 is 5, squared is 25. So the distance is the square root of 50, which equals 5 square root 2. Whew. Okay, so just to prove this, I want to show you that I graphed y equals x plus 10 and the origin point, and then I took y equals x plus 10, and I know that the slope is 1, so therefore the slope of the perpendicular is negative 1. So I did the point slope formula 0, 0, so it would be y minus 0 equals m times x minus 0. And so that is just going to be y equals negative x. So this is the equation of the perpendicular line going through the origin that's perpendicular to this. So I put y equals negative x, y equals x plus 10, and the origin in this graph to show you that the origin, y equals x plus 10, is right here, and this is y equals negative x. And I found the point to be negative 5, comma 5. The point is negative 5, 5, and that distance is 5 root 2. So think about that. If I have a 45, 45, 90 triangle with the side lengths 5 and 5, 5, x, x, x root 2, 5, 5, 5 root 2. Mind equals blown. Okay, so anyway, let's do C. All right, getting a feel for this, I hope. A lot less work doing this than it is doing all of this. Okay, this is definitely an easier way to do this. So let's just move it down so I can still see my graph, or not my graph, but my formula. And let's switch to blue, and let's go. D equals the square root of parentheses. So I'm doing this, P plus Q minus M. Again, it's zeros, a lot of zeros. P, this is P, this is Q, M is 1, and B equals -6. Yes, slope of 1, y-intercept -6. So here we go. 0 plus Q times M minus B -6 times M over 1 plus M squared minus P all squared. So that's just this piece here, plus parentheses. Now I want an M1 times P0 plus QM plus Q times M 2 times, or 0 times 1. Let me just use dots instead of parentheses. Okay, 0 times M, and then minus B, which is -6 times M, which is 1. So I'm right here, all over 1 plus M squared. 1 plus M is 1 squared, close parentheses. And now I want to add B, which is a -6, and subtract Q, which is 0. And square that. Okay, that's a long formula, but it's still not bad. It's better than the alternative. So 0 plus 0 times 1. Well, 0 times 1 is 0. 0 plus 0 is 0. Minus a -6 is a +6. So from all of this up here, I simply got 6 over 1 plus 1 squared is 1. 1 plus 1 is 2. Minus 0 is just simply 6 over 2 squared plus parentheses 1 times this. So that's not going to change anything, this 1. 0 plus 0 times 1 is 0. Minus a -6 is again plus 6 over 2. 1 plus 1 squared, quantity -6, and then all of that is squared. So I should have a parentheses for that and a parentheses there. Yes, yes, yes. Okay, so this is going to be D equals the square root of, well, 6 divided by 2 is 3. 3 squared is 9, plus 6 divided by, oh, I forgot my squared. Okay, don't forget that squared. That squared. 6 divided by 2 is 3. 3 minus 6 is -3. -3 squared is 9. So the distance is the square root of 18. Okay, let's simplify that square root of 18. So I take 18 and do a factor tree. That's 2 times 9, and 9 is 3 times 3. There's my pair of 3's and a lonely 2. So this is going to equal 3 square root 2. So this is the distance from the origin to a point on the line y equals x minus 6. That makes the line from the origin to this line perpendicular. Woo! Okay, that was fun. Okay, that is the end of lesson 15. Go do your problem set.